Welcome to the TypeScript Crash Course, tailored for developers who are either new to TypeScript or looking to sharpen their skills and learn it, especially in the context of using it with Next.js or React. Now, this guide will cover the essential TypeScript concepts and features, complete with code examples. These are all that you'll need to effectively use TypeScript in a Next.js or React environment. So what is TypeScript? Well, TypeScript is a statically typed superset of JavaScript that compiles down to plain JavaScript. And what that basically means in lay terms is that it is a flavor of JavaScript. It isn't JavaScript necessarily, but it is backwards compatible with JavaScript. So if you created a TypeScript file and wrote only JavaScript in it, it for the most part would work. But all we're doing is essentially on top of the JavaScript, we're adding some syntax. So below it says we're adding optional static typing, interfaces and other features to help catch errors early in the development process and make your code more predictable and easier to maintain. And that's absolutely it. So we're adding further syntax to your JavaScript to make it more type safe. Type safe meaning when you can predict from one side of your code to the other what your results are going to be, and that you are expecting the same type of information from one end of your code all the way to the other end, so end to end. That helps reduce errors, it helps catch bugs very early on, and it's been proven statistically that it is a much safer way of writing applications and catching bugs early by writing code that is statically typed. And TypeScript comes with a whole bunch of other features, advanced features as well, that helps you do this. So we're going to have a look at some of the core and key concepts of TypeScript to help you with that. So just to break that down a little bit more, TypeScript is a programming language that builds on JavaScript by adding features that help you catch mistakes early, just like we mentioned. And it's like having a helpful guide that ensures you're using the right pieces in the right places when building a website or app. So you might not know that you've come across an error, you're not sure that you've had bad information come into your application and is trying to pass through the other side with this bad information. But because you've used TypeScript, it catches that early on and says, no, that isn't what we're expecting. That is an error, and lets you know. So it does this by checking your code as you write it. So TypeScript helps you avoid common errors, making your projects more reliable and easier to manage, especially as they grow in size and complexity. And that is absolutely key. When we think of things like Next.js and React and some of the big companies and some of the big projects and websites like Netflix, Reddit that use it, it is absolutely crucial that you help avoid very common and preventable errors, and on scale that you have a huge amount of reliability in the data that you're working with on the front end and in the UI. And that's where TypeScript comes in and really shines. So here are some of the key benefits of TypeScript. So number one, this is the biggest benefit, is type safety. So when we say type safety, we're talking about, let's say, for example, we have a string or a title that is a type of string, and we're trying to pass that information through, and somebody puts a number in instead and tries to put a number as the title. Well, that's not what we're expecting, and that's not what the user is expecting either. So we have types there in place to have a safety net to prevent these types of things from happening, this mismanagement of data and this safety net really for your front end, and basically helping catch mistakes early before your code runs, and which is a huge benefit of TypeScript. It's really clever as well, so it's good at smart guessing, even if you don't explicitly tell TypeScript. So explicitly being you set the type explicitly, so you hard code the type and you say, I definitely want to expect this bit of information. TypeScript actually knows that, okay, well, you've had it like this before somewhere else, so this is generally what you're expecting on this other component in this other place on the website in your application, and lets you know, and does give you errors and does implicitly tell you what to expect. So it's quite a clever so it's a very clever thing. So TypeScript is quite clever. And it's very good at creating blueprints for your data and for your front end. So we call it blueprints, but the real technical name is interfaces. And the lesser known one is type aliases, but the main one is interfaces. And blueprints is a really good way to describe it because that's essentially what it is. It allows you to create blueprints for your data called interfaces, ensuring that your objects and structures follow a consistent shape, making your code easier to understand and maintain. And as you progress as a developer, a lot of the time what you're going to be doing is handling data. And if you're going to be handling data, well, you're probably going to be searching for bugs that appear on the front end because of data. Well, now, if you're going to do that, why not have something that really, really helps you and helps you prevent errors from happening in the first place and helps you find errors when they do happen much, much faster, hence TypeScript and interfaces in TypeScript. And beyond that, it's got very flexible types. So it's not super rigid, like something like Rust, for example. TypeScript's system is flexible enough to handle complex scenarios, allowing you to mix and match types or create reusable patterns, which helps you write code that works in a variety of situations. So very similar to JavaScript, it is quite forgiving. So JavaScript, even if you have errors and problems, it still mostly lets you run. And TypeScript is fairly similar. TypeScript is fairly similar depending on which setting you have. So TypeScript has a strict mode, which would prevent you from doing things like that. But generally, it is quite forgiving with your types. But it does remind you that there is an issue, there is a problem, and you should probably solve it. Very similar to JavaScript. And lastly, better tooling. So TypeScript makes your development tools like code editors smarter by offering features like code suggestions, error checking as you type, and easy code changes, making coding faster and less error prone. Now, a little known fact is that Visual Studio Code, the editor we've been using, which was created by Microsoft, was actually made with TypeScript and was made with TypeScript in mind. And it was a real triumph of basically Microsoft's development team that they created Visual Studio Code and TypeScript at the same time almost and brought it all together with the introduction of Visual Studio Code. And that's right. And yeah, you heard that right. Microsoft created Visual Studio Code and also created TypeScript. Two of the biggest known proponents of front-end development and coding in general is the idea of introducing type safety to the masses, to all the developers through TypeScript, and also introducing Visual Studio Code. So generally, Microsoft is really, really good at creating open source projects like this. And nowadays, when they get involved with projects like this, it's going to be good if Microsoft has got involved, which was a complete 180 on where they were back in the Netscape Internet Explorer days. So it's good to see that transition and that progression. Now, Next.js and TypeScript. TypeScript ensures type safety in your React components. And keep in mind, Next.js is essentially a React framework. So TypeScript works really, really well with React. And TypeScript is fairly well aimed at React as well. You can see it on their front page. It's also very good in Angular as well, but we're going to be focusing on React and Next.js. And you can use it on your Next.js and React components. So on your React components and your Next.js pages. And it helps reduce runtime errors, improving the developer experience by providing better auto completion. So auto completion being if you try to type a variable, it'll automatically give you the right type or interface to add as a type safety net for whatever you're working on. It's great for refactoring and code navigation in your IDE as well. So something like Visual Studio Code or WebStorm. Now, most modern projects that use Next.js at a company will more than likely be using TypeScript. I know that for a fact. I've worked at several companies and nearly all of them have used TypeScript, or they've asked me personally to come in and convert it to TypeScript for them. It is a really sought after skill. It is when you scale up to, let's say, for example, a company that I worked at, we had initially just a handful of developers and I was one of the founding engineers. And when we came on, it was all using JavaScript. And essentially the goal was from the CTO, he asked me to basically push forward the want to convert everything to TypeScript. And it was a very good decision because he knew in the back of his mind, he wanted to have 8 front-end developer teams or 10 front-end developer teams, which we eventually got. But the genesis of that was being able to create a development environment that would allow us to scale up really high. And TypeScript really does allow you to scale up and create very type-safe projects that you can rely on the data, that you can be confident when you put that forward, there is something there to help you prevent bad data coming through and to have some confidence in the information you're putting on the UI. So big companies massively love this. Both the companies I spoke about are billion-pound companies, and even smaller startups absolutely love TypeScript as well. So as a skill to enter the job market with, TypeScript and Next.js are amazing, and learning to use them together is going to be really invaluable for yourself. With that in mind, let's set up TypeScript in a Next.js project of ourselves and go through the fundamentals of TypeScript together. So let's get started. So this is the official TypeScript website. This is typescriptlang.org. And on here, it will give you a rundown of what TypeScript is, because you can use it on Windows, Linux, Mac OS, Angular, React, and the list goes on. You can use it with most frameworks today. And this is a really good breakdown of what TypeScript is. So it's essentially JavaScript, but just a little bit more. It adds additional syntax to your JavaScript to support a tighter integration with your editor, and it catches errors early on in your editor. And it's results and a language you can trust because you can rely on type safety from end to end on your project. And like JavaScript, it can pretty much run anywhere because it converts your code down to JavaScript. So it allows it to run anywhere once it builds it. And generally how you build it is using Node.js with a Node package manager or something similar. And then obviously safety at scale, which we already spoke about. And TypeScript understands JavaScript and uses type inference to give you great tooling. So basically it predicts what your types are going to be and has a very good eye for knowing what your types are going to be. And if it doesn't, it simply doesn't imply that, and it allows you to correct it. And this gives you an idea of how it works. So one thing I would recommend is, rather than installing it manually, we'll install it via the terminal. But here we've got the docs section here. So if you go to the docs and go to TS for the new programmer, it is a brilliant write-up. So if you've never done TypeScript before, I would highly recommend going to the docs section and going to the TS for the new programmer in the get started section and just have a really good read of this. And it gives you a good history of JavaScript and TypeScript and how it came about, and all about static typing on a very basic level. And it's really written well, so it's good for the layperson as well. But we are going to look at introducing TypeScript with Next.js, because Next.js is the final evolution of you as a front-end developer. If you want to become a React developer, then Next.js and TypeScript is the way to go. The styling side of it is up to you and depends on company to company. But one thing that you can rely on is that most jobs you're going to apply for are probably going to want to do Next.js and TypeScript. Now, there is a very simple way to install TypeScript in your project, and that is just run the default npx create next app latest. And as you can see here, it ships with TypeScript by default. Now, in the past, create next app had to have these unique conditions to do it. So you had to add a template, but it's fine to do it like this. So I'll show you what template I'm talking about. So you can see here when you run through it, you get asked the option, do you want to use TypeScript? And we'll choose yes. So let's go ahead and do that now, rather than putting in a command in the terminal to specifically download it. So let's open up Visual Studio Code. We'll open up our terminal. Now I'm going to use Command J to bring it up, and you can just press View Terminal up here, or whatever command you have. If you're on Windows or Mac OS or Linux, it'll be different, but make sure you bring your terminal up because we are going to create a Next.js project. So I'm going to go into the folder that I generally want to create it. So this is the tutorials folder for me. So now I'm in my tutorials folder. I'm going to run the command npx create next app at latest. So paste that into here, and I'm going to call it Next.js TypeScript. It says you need to install the following packages. That's fine. Would you like to use TypeScript? Yes, I would. Would you like to use ESLint? We'll go no for now. No to Tailwind, no to source directory, yes to the app router. Would you like to customize the default import alias? No. And it's installing. Brilliant. And then we'll just cd into the directory once it's installed. First, I'll just clear all this. So cd Next.js TypeScript. There we go. And then I will do pnpm dev, but you can run npm run dev if you're not using pnpm, and it should work fine. So we'll do that for now. And then it says we're running on localhost 3000. So we'll open that up, refresh that, and that's our Next.js project. So we're going to open up the console here because we're going to do a lot of console commands. So I'll make this a little larger. Okay, and let's go back to our project. Now, what I want to do is essentially, I'm going to just stop the server for a moment. I'm going to press code dot. I'm just going to clear this and then type code dot, which will essentially open up our project in VS Code in another window. And then I just make it large enough. And there we go. We're now in our project. I'll just close the welcome window down. I want to show you what the app router looks like when you've installed TypeScript. So in the past, we've had JS files and JSX files. But when we've installed TypeScript, everything is TSX, except for the TypeScript files. A TypeScript file would be something like this, index.ts. And essentially, it would just be TS instead of JS. And that would simply be it. So I'll delete that for now as we don't need that. And we can see our page, and you can see that there's not any type safety on here yet, but we'll just delete all this. And I'll just put a H1 of Next.js TypeScript. Okay, and refresh this. Oops. Oh, and just make sure we're running the server again. So npm run dev or pnpm dev. I'll run pnpm dev this time. And then I'll close this down, refresh, and then just refresh this. There we go. Next.js TypeScript. So we can see our layout.tsx is also using TypeScript, and we can see there's already some types on here. So originally, if this was just JavaScript, it would not have this, which is a type of metadata, but it has been typed with this blueprint of metadata. And if you hover over it, it tells you it's using the interface of metadata. And if I left click that, this is essentially what it is. And someone's added a lot of comments to help explain what each one does, but it gives you an idea of how we're defining what each one is. So this is a generator type, and it's expecting this value, either null or string, and it goes on. Now we're going to break down into this in a moment, but just giving you a very brief look at TypeScript. And then, children here has been typed as React Node, so it can use basically JS. And we've set this to read only. So there's quite a lot of TypeScript already in here as a little spoiler as to what we're going to look at. But we'll close layout.tsx down for now. And we'll go to page.tsx, and we can delete image up here. Further down, we're just going to have a look at the next environment d.ts. And this is just some global types and global references for TypeScript in Next.js. So this is just something you shouldn't bother moving or editing or amending. So we'll leave that. And then we have our next config, which stays the same. And then our TS config. Now this is unique to TypeScript. And this has all your TypeScript properties in here and is one of the most important files in your project for TypeScript. So in here, we've put strict mode on as true. And if you hover over that, and it says enables all strict typing options, and then it will go into more details if you left click here, and it will take you to the website. So this tells you all about strict mode. So the strict flag enables a wide range of type checking behavior that results in stronger guarantees of programming correctness. And turning this on is the equivalent of enabling all of the strict mode family options, which are outlined below. So then it goes into detail about all the different strict mode options. But it basically gives you stronger typing on your project. And generally, any project I'm on always has strict mode on, because really you want the benefits of TypeScript, so why not use strict mode? And then there's just some other settings on here as well that as you get used to TypeScript, you'll start to know as well. So it's added the alias here, which is typed. And it's typed some other files on here and just included them. And it's saying, I don't want to check types in the node modules folder. So we've got an exclude section, and we've actually got a include section. So this is all the stuff we want to include. So anything that ends in .ts or ends in .tsx or types, ends in TS as well. So quite comprehensive. That's all we need to know about tsconfig.json. Now, just as a note, if you are trying to add TypeScript to an existing project, what you would certainly need is a tsconfig.json. So I'd use the touch command in the terminal to basically create a file. That's what touch does. The touch method basically just creates a file, whatever you call it, in wherever you put it. So I could put it in a certain folder here if I wanted. But if I don't add anything after here, it's just going to add it in the root folder. So you add that and then you put the settings in. And then after you've done that, you need to install the following. So you would need to install TypeScript, Types React, and Types Node. For any React project or Next.js project, you want to add TypeScript, and just make sure you put the save dev flag on if you're using npm. Makes them developer dependencies, so it doesn't actually go to the user in production. Okay, but because we've already got it, we don't need that. So within here, we're just going to create some TypeScript. So some very basic TypeScript here. So just within here, we're going to create a few variables. So we're going to create let message, and we're going to say that is equal to hello TypeScript. Now, this is a variable, and it's the variable called message. And very interestingly, we haven't explicitly typed this because we've not added a type to this, or a static type. To add a static type to line 4 here for let message, what we'd need to do is where it says the variable here, we would do a double colon and put in string. And essentially what we're saying is our expectations are being set, and the expectations are that this variable is going to return string or a string, and that string is coming in the form of hello TypeScript, but it doesn't have to be this exact bit of text. It could be anything as long as it's within these two quote marks or a single quote marks, and it's a string or even a type literal. And I know this because if I delete this, TypeScript is clever to know, based on what the value is inside this side on the right hand side of the operator, that if I hover over this, it already knows that it is a type string. So it says here let message double colon string, and it said that before I even put that in. And that's because TypeScript implicitly knows, based on the value you set for a variable, what your value is going to be. So for example, if I then change this to a 23 and then hover over it, it then changes the implicit type to number. And this is what we call implicit typing. But if I was to statically type this, and I would say this is a number, well, then this would also say a number, and that would be in line with what I've statically typed it. And I can test this by changing this to a string. And what you'll see is now there are red squiggly lines under the variable. And what it says is type string is not assignable to type number. And this is where we go back to the idea of TypeScript adding a little bit of intelligence to your code, that it allows type safety, it enables type safety by enforcing the types that you statically typed. So for example, if I didn't statically type it, it wouldn't error because I haven't told it to be a certain type. And if I hover over it, it changes the implicit type. So you're starting to get an idea of how TypeScript thinks, how it works, how it's been made to work. And I'm going to change this back to number, and then I'm going to change this back to 23. And that's absolutely fine. So let's turn this back to a string, and I'll put this hello world, and then we'll add another one. So we'll say count, and we'll statically type this as number with a double colon, and we'll put 42. And we will then do another type as well. So we'll do let is logged in, and we'll say equals true. Now you notice I haven't statically typed it and there's no error, but that's because it's implicitly knowing that it's going to be a Boolean, because true is of type Boolean. So if I then said Boolean and change this to true in quote marks as a string, it then says type string is not assignable to type Boolean. So just like we did before. So we'll do it like this, get rid of the quote marks and keep it as a Boolean. And that is the general idea behind static typing. And we can test this in a function. So function add a type number, b is type number as well. And then we want to return number here as well. And return a plus b. And then all we're simply doing is console logging that. So we add, which is the add function here, and we'll just pass in some numbers. So we'll say 2 and 3, because those are the two parameters here, A and B. Okay, and then what we want to do is we just want to console log add and pass the parameters of 2 and 3 as values to add together. So you'd expect the number 5, and that's what we get. So we're getting 5 back, it's working correctly, but what if we set 1 to string? Well, it does the calculation, and like we said, TypeScript doesn't allow your code to prevent being shown on the website, similar to JavaScript, but what it does is it gives you errors in your browser, or sorry, in your IDE and on your pipelines, and tells you that you have an error. Argument of type string is not assignable to parameter of type number, which is absolutely correct. This is a string, we're expecting a number, but if I said string here, well, then that would be correct. Now the return here is saying type string is not assignable to type number, and that's because we've set this to be number here. This return type, so this OR operator, so if this should return number or string, well then it's correct, because this is essentially what we're expecting. This is the guarantee or the contract from these parameters of what we're returning. So if I delete this now, well then it's still giving me an error. So there's many levels of security in TypeScript, in a function, in different parts of your app that try to remind you, okay, no, this is really what you should be doing. So I'll change this back to number. And now the error is essentially telling me the error isn't in the function, because that's where the red line was. So the error is over here. So it even directs you where you should go and solve your problem. And again, this is why it really helps you solve problems in modern applications. I'll change this to 3, I'll refresh that, and there we go, that's working again. So that is type annotations. So type annotations allow you to explicitly specify the types of variables, function parameters, and return values. Now next, we're going to have a look at interfaces. So interfaces in TypeScript are used to define the structure of an object. And objects are very important in JavaScript in general, and especially TypeScript. And the more complex an object you have, the bigger reliance you need on something like TypeScript to be able to know from start to finish what your object is going to look like and what you're expecting from that data. So we'll create an interface now, and I'll show you what this is. So in fact, we'll create the interface up here outside of the function component. So we'll say interface and we'll say user. Now interfaces don't have, then after that we just do open curly brackets and open that up, and we're going to pass in a few properties here for the interface. So we'll have ID, and we'll have it as a type of number, and we'll have name as a type of string, email also as a type of string, and is admin as a type of Boolean. Now interestingly enough, if you want to have one of these properties as optional and have all of these as required, it's very simple to do. Just before the double colon, add a question mark, and then that becomes an optional property. And what I mean by that is essentially you then don't have to add it in the object if you don't desire, and you can also just add it as an optional thing. So we're not expecting it to be there, and that's the important thing. You can start to create components. So you can imagine this being props in a React component, and we're saying these 3 we definitely need, but this one we don't need it for every single component implementation for it. So it can be very useful with React. And down here we'll just create another one. So down here we'll actually use it. So we'll say const. In fact, we'll add this within our function down here, our component. So we'll go const user. So that is the variable, and we're going to type it with type user. Well, I say type, it's not a type, it's an interface. And even when you hover over it, it tells you it's an interface, and that is from up here. And then we're going to set the object as ID as 1, name Harry Ashton, email as harry@ashton.com. Oh, and of course we forgot to add the equal sign here because we are creating an object. So if you're creating an object, it's the name of the object as a variable equals, and then the curly brackets, of course. And it's ID1, name Harry Ashton, and email harry@ashton.com. user.com. And we're going to use this user actually in a function. So we'll go function. So we'll go const print user, and we'll create an arrow function, and we'll console log here. And we're going to do a template literal, but in here, we just want to pass the user. And what we're going to say is user equals user.name. And then here we're going to pass user.email and then close this line off. And then just down here, we're going to print the user and pass in the user object. Now you can see there's a red squiggly line here because what it's saying is you are implicitly using the any type. Now, any is a unique type that we haven't seen in JavaScript before in our previous videos. Any is something that is unique to TypeScript, and it is a type where if you're unsure about what to add as a type, you can simply go any, and that solves your TypeScript problems. And in fact, you could create an entire TypeScript application using any. But the problem with any is it is very much a developer tool. It is not meant to be used in production if it can be helped. There are very, very few use cases where you actually need to use any in a production environment, because you do want to statically type, because if you use this, well, then you defeat the whole point of using TypeScript. But it's a good way to essentially put a plaster or a band-aid on a situation. It's not a long-term solution, because the long-term solution here is to type this correctly. So for example, it's now saying implicitly it's a type of any. Well, that's not correct, because the type is over here, this interface. So we're going to say this is a type of user. And now when we hover over all these variables, it knows exactly what the type is. It's a type of string, that's a type of string, and this is of the user type. And this knows that this is the interface user. So if I press command and hover over it, it then opens up what the interface actually is with all the properties. ID, name, email, is admin. And it even tells me that is admin is an optional property because I added that as a comment. And quickly you can start to see how much control you can add to your information, to your data, and you can make working on a project so much more reliable, and you understand what you are to expect. Because sometimes if you created something months ago or weeks ago, and then you come back to a project to work on it, and it may even be a section you've never worked on before, but if you've used TypeScript, you can just go over here and go, okay, right, that's what I'm expecting to have, because somebody added a TypeScript interface here that tells me exactly what I need to add. And this probably is a problem, or this is a problem, and you'll figure out through TypeScript where your problems may be coming from. So it's great for scaling up in larger teams, and it's great for working with other people. So we've added a lot of this into our page.tsx, but if I was to create a new folder, so out of here, I'll create a types folder, for example, and in here, I'll create a page.types.ts. And this is essentially a types file. You don't have to add types, but generally it's a good practice to add types to understand what you're adding. So if I grab interface here and just cut that, I can take that out as well and put that into here. And all I simply need to do is type in export interface. And now this is available throughout the project, because all I need to do is go import user from types pages.type. And it's saying has no default export, so that's fine. So just down here, we'll go export default user. So we just make sure that this is the default export. And we can see that this is now still working just as intended, because if I left click that, it now takes me to this types file for the page. And we can probably rename this because we don't need it to be the pages types file. It's actually the user types file, lowercase because it's not a component. And then just make sure this is updated. So user, and that's working fine. Now I'm going to show you some best practices for TypeScript interfaces. So I've worked with people, and I've also interviewed Microsoft and spoken to lots of Microsoft developers. So I get an idea of what some of the best practices with TypeScript are. And one of them that they use at Microsoft themselves is this. So whenever you're creating an interface or a type, so for example, this is an interface, and there's a lot of benefits of creating an interface. I'll show you one of them in a moment. So if I create but I'll show you that in a moment. But for now, this is a best practice. So if you type in user and then you put it I before it, well, essentially what you're saying is that this is an interface. And just by looking at the name of it, you instantly know by the convention of what you've added here that this is an interface. So if I go to page.tsx and I go import iUser, and I just make sure these are all changed here, instantly when I'm glazing over this, I can see that iUser, okay, well, that has to be an interface. Well, that makes sense. And then I can use that knowledge at a glance to be a little bit faster, to be a little bit quicker at problem solving. And I can highlight that if I create a type here. So if I create a type, so I'll say, so type address, and types are slightly different to interfaces. I'll make sure I export this as well. So these are slightly different. So normally with an interface, you would just do that, just do open curly brackets, but that doesn't work. You have to do an equal sign because it is an object. So because it is an object, you then need to do an equal sign with the open curly brackets. But we've created a type now, and these are one of the two major things that essentially adds type safety to your project. And I'll show you how we can use a type. So generally, as a best practice, you want to add a type first. And the only reason you would add a interface is if you want to essentially extend your types. And I'll show you what I mean by that by creating some types here. So I'll create address. So I'll put house number, and I'll put string or number, because it could be a string or a number. So I'll put this as string. So I'll put this as number, and then I'll put address here as string, street address, a string, and then I'll put postcode, or you could put zip code, whatever you want to put. So I will put postcode, and then you can put string here as well. And then you would put state or county, whatever you want to put. So I'll put county string, and then I'll put country string as well. So that is our type address, and all you do is within here, you can go address, and I'll add it as an optional type, and I'll set the type of this rather than trying to type all this out individually and having this giant object within here with all these types, and it starts to look a little messy, a little untidy. All I do is I put in the type address here and I close it. And essentially what this is doing is this is saying, well, within the address property here, I'm actually expecting an object with all of these types or values within it. So house number, street address, postcode, county, country. And then if I want to create a new interface but with slightly different information, for example, I don't want to use the address type here, I'll simply go down here and go export interface. You don't have to export it, but generally you can if you want. And I'll go iUser min. So this is a minimum version of this. And then within here, I will pass. So to extend an interface, this is all you do really. So we'll go down here and we'll create a new interface. So we'll call it interface iUser. So this is a very UK version of this. And we'll say address UK here as the type. And I'll say to extend this iUser here, I will say extends iUser. And essentially what we're saying is this new interface I've created here is just going to extend this iUser here, but we're going to make some changes. So the changes are this. So ID, name, email, address, is admin is all going to stay the same. The only thing that I'm going to change is the address. So I'm going to go address, keep it as an optional, but I'm going to create a new type here. And I'm going to change this to US, and I'm going to change this from county to state, postcode to zip code, and the rest can stay the same. And then all I do is I pass in address US, and I'll just add a new property address US here. So what this is doing is if it's a US property, it's actually going to add this information, and it's going to add it on top of all of this other information. So imagine essentially what this would look like once it's compiled or it's used in the real world would look like this. But in reality, all the code actually looks like is this, which is quite small. And that is how we extend an interface. And that is the power of interfaces in TypeScript. And they really do help you define a structure of an object. So we'll go in here, and one final point on this, as we were looking at types, is as we said, there is a best practice for adding an I before an interface. Well, it's the same thing for a type, except that you add a T. So it'd be T address UK. So we just add a T here. And that helps you know that this is a type. And then we can just simply make sure that this is Pascal cased by adding a capital A. Now this is using Microsoft TypeScript best practices. And since Microsoft created TypeScript, you'd expect their software engineers to basically be using TypeScript in the best way possible. So these are standards from there. Not every company is going to use these standards, but it's good to know that you can do it like this. Right, let's go back to our pages component, and we can delete all of this now. And what we're going to look at now is type aliases. Now, type aliases allow you to create custom types by giving you a new name to an existing type. And I can show you that by creating the type ID, and we'll give it the type of number or string. And if we type in let user ID equals ID 123, that is essentially, that essentially is going to be a number, and that's what we're expecting it to be. But because it's a let, we can actually, so type aliases are essentially what these were here. So these were individual types to use in an interface. And I can show you how we can actually use these in sort of maybe a more real world case. So we've created a user ID here, and we'll go user ID equals ABC123. So we've basically changed it from type number to then type string. And then we'll create a type here called callback, but because it's a type, I'll add a T here just to denote that it is a type. And then I'll go result Boolean, and it will be type void. Now type void is similar to any. It's kind of a nothing type. So it's saying we're not really expecting anything. Type void in JavaScript essentially is similar to Java, where void is where there is no data. So if a function doesn't return any value, then you can specify void. So that is just the idea that we're not returning anything. We're not expecting anything. So void is okay to use. And that's all it is. And that is the type T callback. And then we're just going to pass a function of process, and we're going to say it's going to be a parameter of result, which will be a type Boolean. And then we're going to add our custom type alias, which is callback. And then we're going to run our second parameter here and pass in our result. And we just need to obviously call it T callback because that's what this type alias is. And then we can delete this import up here. And that's basically how we create a custom type alias. And you've seen we've done that already here. And we've used this within an interface, but this is how we create a custom one in our Next.js component within a function. Now, in terms of core TypeScript, that's pretty much a lot of what you need to know. That is like the very, very basics of TypeScript, enough for you to get on with TypeScript and start working with it, create types, create interfaces, and be able to extend interfaces and be able to use type aliases within interfaces and create your own type aliases. You now know the any command, which will help you solve a lot of type issues if you ever come across them. If you get stuck, just use any until you can figure out the correct type, and use type void if you want the function to return nothing. So all those tools are enough to be a valid TypeScript developer on a very basic level. But what I'm about to show you are a few more advanced concepts in TypeScript. So the first one we're going to look at is generics. So generics are a major part of software engineering, and they're used for building components that not only have well-defined and consistent APIs, but are also reusable. This is a feature that's pretty much come from C# and Java, and they're one of the main tools in those languages for creating reusable components. And that is the idea of being able to create a component that can work over a variety of types rather than just a single one. So as we've seen in the past, we've tried to define our functions with a singular type of type, but what generics does is that allows you to have a range of them, and that allows them to basically add their own types with this based on the situation that they need. So what we're going to do is the hello world of generics. So to start off with, we're going to create an identity function. So just down here, we'll do function identity, and we'll say the first argument is of type number, and we're expecting number to return from here, and we're simply going to return arg, which is argument. Now this identity function is a function that will return back whatever is passed in. You can think of this in a similar way to the echo command. So basically you put whatever you want in the echo command and it just returns it for you. Now without generics, we would either have to give the identity function a specific type, or as shown here as type number, or we could describe the identity function using the any type. So basically changing this to any and the return here as any as well. Now while using any is certainly generic in that it will cause the function to accept any and all types of the type of arg, we actually are losing the information about what that type was and what the function returns. If we passed in a number, the only information we have is that any type could be returned, which isn't very useful. Instead, we need a way of capturing the type of argument in such a way that we could also use it to denote what is being returned. So here we're going to use a type variable, a special kind of variable that works on types rather than values. So if we go here and we'll create a generic of type, and you can see a generic is when you add it within these pointy arrows and put in a value, and that is your custom type. So we'll pass type here and we'll return type as well. We've now added a type variable type to the identity function. Now this type allows us to capture the type the user provides, i.e. number, so that we can use the information later. So here we use type again as the return type on inspection. We can allow the same type is used for the argument and the return type. This allows us to traffic that type information in one side of the function and out of the other. Now we say that this version of the identity function is generic as it works over a range of types, unlike using any. It's also just as precise, i.e. it doesn't lose any information as the first identity function that used numbers for the argument and return type. Now once we've written the generic identity function, we can call it in one of two ways. The first way is to pass all of these arguments, including the type of the argument, to the function. So you can do it like this. So for example, let output, and then we pass in identity, and then we're going to pass in our custom generic type of string, which is outlined here, and we're going to put in our value here in the parameter for argument. So if you hover over it, it then shows you the function generic type there as well. So that is explicitly setting the type to be string as one of the arguments to the function call, denoting the use of the pointy arrows around the argument rather than a parentheses. The second way is probably the most common way, and here we use type argument inference. That is, we want the compiler to set the value of the type for us automatically based on the type of argument we pass in, which is implicit typing. So I'll comment this out and I'll write it here. So let output equals identity, and we'll pass in my string. So we're not using these generics here between the pointy arrows. We're simply implicitly saying, well, this is string and that's what it's going to be. So if I go in here now, you can see that for the function, it is now saying that the types are always going to be my string. So it's always expecting my string. So if I go here and I say output is equal to my string 2, output. So it's saying it should be equal to my string, and that's fine. So if you put this down to that, so if I change this to a number, well, that's going to error out. So that is working correctly. So notice how we didn't have to explicitly pass the type in the angle brackets, which is the pointy brackets here. And the compiler just looked at the value of my string and set the type to its type. And that is implicit typing with generics. And that's how you could use that. And that gives you a general idea of what generics are. A lot of people, what they do is they shorten this. So instead of using the word type here, they just use T. So if you ever see this in TypeScript, that's what they're doing. They're creating these generic types that are giving the user, yourself, the developer, the option to choose whatever type you can put in here. And it's a stronger any in that regards. So It can be a powerful tool to use, but my advice would be, as a developer going into a code environment where other developers or senior developers might be using generics in TypeScript, is to understand what's happening and to understand what they're doing. You don't necessarily have to use generics in your code. And to be honest, it's very rare that people do use generics in TypeScript code bases on average. Some people do. On more advanced code bases, they will. But this is just something good to know because it is one of the more common things you'll see in TypeScript out of the advanced concepts. So that is generics in TypeScript. Now, the next thing I want to look at are enums. And enums are a great way to define a set of named constants. So before we've set values and items as strings, but we can actually specify what those string values are. So for example, if I create an enum of role, and again, like an interface, you don't need to have an equal sign for an enum, and we'll put in user equals user. So this is great for creating user types and user roles. And then we'll create another one called admin, and we'll say the type is, well, the value should be admin, the enum value. And then we'll say super admin is type super admin. And then we just put an underscore here. Okay, so again, because this is an enum, you can pass in an E if you want, just to denote that it is an enum, but it's totally up to you. I'll put an E in for now. And then what we'll do is const current user role, and we'll pass in the role, and we'll say that is equal to role admin. Obviously pass T role here. Whoops, not T role, E role, obviously because it's an enum. So if I was to then hover over here, it gives me all the enum values, and I also get type. I also get auto suggested all the other types. So if I go here and I type in a dot, I can go choose user or super admin or admin. And that is one of the big benefits of using TypeScript in a way like this, is that if you know that there's always going to be a set of few options, you can add it here in an enum and use it in your project. So you know that the backend is always going to send in a type of user admin or super admin for E roles. Then you can just set an enum here, which essentially translates this enum here into this value. And you can set this to whatever you want, but essentially that's what it will console log out to. And you can use it in your logic as well within Next.js. So for example, if current user role, which is this type here we've created, is equals to role admin, E role admin, then I want to console log, you have admin privileges. We'll close that line off. So currently we've got that set to admin. So if I refresh that, you have admin privileges. And if I change that to user, it returns nothing. So I'll do else, and I'll do console.log, you do not have admin privileges. And what I'll say is I'll return here E role. So we can see here, this point here, a current user role is set to E role. So currently we've set the E role type to be E role user, but if I just deleted that, and you can see that's not happy with it because that's not coming in as admin. So I'll change that back to admin, and that should be fine. Oh, just make sure we spell that correctly. Refresh that, and there we go. You have admin privileges. And that essentially is enums. Okay, brilliant. That is enums. Okay, let's have a look at union and intersection types. Now, union types allow a variable to hold one of several types, while intersection types combine multiple types into one. So I'll show you what a union type is. So just as we looked at enums, that is one way of basically passing in a type value. Another is union types, which is generally the preferred way of doing what we just did. So I'll do a type of status, and I'll say success, error, and loading. And you'll notice that a lot of component libraries, things like Material UI or Shad and CN, generally use this type of a typing for their components. So then if I create a variable and I'll call it status lowercase, and I'll type it with status, and I'll say I want the status type to be success. So just to go over this again, this here is a union type. So it allows a variable to hold one of several types, in this case status, so it can be success, error, or loading. And then I'm going to show you interface types below. So interface types. So here we have two interfaces of address and contact. So one takes street and city as strings and email and phone as strings down here. And then all we're simply going to do is we're going to combine these two types by doing this. So we'll create a new type called profile, and we'll say it's equal to address and contact. And that is how we create an intersection type. It simply combines multiple types into one. And that's how easy it is to create an intersection type. So this essentially becomes one new type called user profile. And then down below, if I want to create a const user profile and I want to make an object, and all I do is I pass in the street and city from address here and the email and phone from contact. So street 123 Main Street, city any town, email john@example.com, phone whatever it is. And currently it's clever enough to know that I've created my own type here, and it's implicitly said, well, this is the type of user profile, but I am going to make it explicit by passing the user profile type here. Then it knows that this is user profile, which is an intersection type. And that essentially is the difference between a union type up here and an intersection type down here. And those are the two ways you can generally use them. And this one up here is generally something you will probably use a fair amount every now and then. Probably more so than this, but who knows what code bases you're going to go into. It's always good to know some of these more advanced concepts. Now, the next thing we're going to look at is typing in Next.js pages and API routes. So in Next.js, pages and API routes can be typed to ensure that props and request responses, that request or response objects are handled correctly. So for example, within here, we've got a function of home. Now, if we wanted to pass the prop of title, generally what we would do in the past is we'd just pass a prop and not give it a type or not bother explaining it any more than that. But once you're using TypeScript, that is no more. We have to do a little bit more to type our components. So we'll create an interface here and we'll say home page props, and you can make it a type or interface. It's totally up to you. A best practice generally would be to use a type first, because unless you specifically want to extend it, I wouldn't bother making an interface, especially for just a single type, which is what we're going to do. So we're going to add the title of string here. And then what we're going to do is just after here, just after this curly bracket, we're going to pass homepage props. And what that's saying is what we're returning from this object is homepage props. And you can add more to here if you want to, but we're just adding the title prop for now. And then within here, we're just going to pass a h2 and we're going to import the title prop, which is this here. So now these two are connected and we're going to pass that prop in. And then we're going to go over to here and create a new folder called API, where our APIs are going to live. And we're going to create a hello.ts API. And what we're going to do is just create some kind of payload. So we'll do export default function handler, and we'll pass in the prop rec for request and res for response. So we'll do response and request. We'll type that out and we'll open this up and we'll pass response.status. If it is 200, then we want to JSON that and pass in the payload of message hello world. Now we can see here that request and response basically not too happy about being any type, and we could just put any in here like this and be done, but it wouldn't be very type safe. But what we want to do is we do want to make it type safe. So we're going to go here, next API request, and we're going to import that. And then here we're going to do next API response. So essentially we're typing the response and request to Next.js's default types, which is next API response and next API request. And if you ever want to find out what's in these types that we're adding, you can always just command left click and it will take you to the Next.js file and you can just go and have a read. It's got descriptions here. It's quite user friendly and it tells you basically what's going on, what all of these are doing, and you can actually see how more advanced TypeScript is written. So for someone here, they've added a generic type and they've extended it with this information here. And you can start to see more advanced patterns in TypeScript, because let me tell you, there are very advanced types in TypeScript, especially if you're writing library code, like the people who create all the things that go in these NPM libraries here. If they're all using TypeScript, trust me, those are some heavy duty TypeScript code bases that are quite very technical. But doing things like that, opening up the types here and having a read through, is how you become a better developer, and how certainly you become a better TypeScript developer, by reading other types and reading other people's code that other more advanced senior developers have made. Okay, so now we've created that. That is now returning hello. And those are the two ways that essentially you can type in your Next.js component. So this Next.js component is being typed here with the props, and this Next.js API file is being typed using these next types. Now we've seen here that we've typed this component here. We'll create a new component outside of here. We'll create a React component. So just in the root folder, we'll create a components folder, and within there we'll create a button component, and we'll make it a TSX file, and we'll say const button, and then we'll return button, and we'll put text in here, on click functionality in here. And what we're going to do is we're going to pass in some props in here. So there's multiple ways you can do this. So you could break it down here, and you could put in your individual props. So on click text, you could do that. So I'd pass in on click and text, and that's how you could pass it in. We'll just make sure we export default button here. But generally, what you want to do to type a React component is this. So similar to what we did in the Next.js homepage, we're going to create a props here. So we'll do export type t button, and we'll say it's equal to on click, which is basically a function handler. And we're not expecting anything here because we don't know what they're going to use. So we'll just say it's a function that returns void for now. And then text as string, and that should be enough. And then obviously we'll just go here and type t button, and that should be now type safe. Now there are other ways you can do it. In Next.js, it automatically knows that this is a JSX element, therefore a React component. But you can very explicitly say that this is a React function component, or function component, which is what the FC stands for. And then within here, you'll pass in a type generic of t button. And that essentially does the same thing that this was doing by itself, but you're being far more explicit, and you're saying this is a React function. And obviously, if you are doing that, you need to make sure you import React from React for that to work. And that generally is the old school way of typing a React component. This is more of a modern way. That is probably a more modern way of doing it. So if you're creating a React component, generally you want to type it like this. And if you don't want to break down all of these components in here, there is another way you can do that. So you've got multiple options and ways of doing this. So rather than having it inline here, and you could have lots of props and it starts to look quite messy, what you can do is simply replace this by deleting these curly brackets, deleting that, and just typing in props. And then what you do is down here, you just deconstruct it. So you do const, and then you create an object, and you'll say on click and text equals props. And that does the same thing as well. So what we're saying is this is a React function component. We're passing in a generic type of t button, and that is then basically props. So if you hover over it, it knows what it is. And then we're going to deconstruct the object of props and get the value of on click and text to use in our project. I'll just wrap this so that is connected as well. And then if I use this somewhere else, so let's say this page component here. So I'll replace this with, what did we call it? We just called it button. So we'll pop button into here, make sure we import it. So we'll add the import here for button, and then it's giving us a red squiggly line. And that's because TypeScript is saying you're missing two properties from tButton, the type we created. And it's saying you're missing onClick and text. So we'll do that now. So onClick, and we'll do a console log. So console.log TypeScript is awesome. And then we'll also pass in a prop that says text, and we'll just put in click this button. Okay, and that is essentially how we create a reusable TypeScript safe component in the most simplest of ways. And let's go check it out in Next.js. So if I refresh this, you can then see the button is down here. And if I click it, it says TypeScript is awesome. So that's a very simple way to add TypeScript to a component. There's a lot of other things you can do to take it one step further. So you can add custom class names. So for example, if I go class name here and I put in a class name here, and I'll add a type of class name and I'll make it a string and I'll deconstruct it here as well. We can now pass in a custom class name here to style in this project. So if I go class name and I'll go custom button or even home button, and then I go to global.css, go to the bottom, and I'll go here home button, padding 1 rem, border 5 pixel dashed red. And then you can see I've passed in a custom class name by amending the types, passing it into my React function component with generics, and it has come all the way down here into the home page. Amazing. And all the on-click functionality still works. Now there is one other thing you can do to organize your component. So we've got the type here, and if you want to use a proper Java separation of concerns, we'll create a new folder here and we'll call it button. So similar to how in React we basically had separate folders for all our components, we'll pop that into there, and then within button we'll create an index.ts and we'll say export default from button. So we're signposting it to this button component here, and then we'll create a new file and we'll say button.types.ts, and this is essentially where we can keep all our types for this component. So if we want to create any more, if we want to create more complex interfaces and type aliases, we can do, but we don't have to keep this logic here now. So I'll take this out, go into button.types and put it into here, then go back to button.tsx and go import tButton from button types. And then we just need to go back here and make sure we do a default export. So export default tButton, and that should be working now. And that is still working, that's still connected. And we've basically just separated the logic out so that it's a lot tidier and neater. And you can start to get an idea of how TypeScript and React just work so well together and create really reliable, reusable functional components in React. So within the button component, I'm going to show you how we can use something called type guards. So type guards are this really great tool in React that really help you with conditional logic. So as we saw in the React project, we were able to do conditional logic to show bits of UI, but we can also use it to do conditions based on types. So if a type is a certain type, so for example, as we saw earlier, the user roles, if one was a user, we'd show this certain UI, but if the user was an admin, we would then show additional UI. And that's how type guards can work with TypeScript and React. So we'll create a function here and we'll say is string. So we're just going to check to see if something is a string. So we'll put value currently as unknown. And again, this is similar to void and similar to any, whereas void is saying this function is not going to return anything. And as any is saying that this could be an any type, unknown is saying, well, we don't know what the type is going to be, because it could be a number of things. So at this particular stage, we don't know what it is. So it's okay for it to be unknown. So that's what the unknown type is. And then we're going to say the value is string. Now, what we've just done here, where we've said is string, is essentially called typecasting, where we're explicitly saying value is string. So we're just typing this on the fly in line. Okay, then we open this up and then we return type of. So in JavaScript, you can check the type of something by typing in type of, and we're going to check the type of value, and we're going to see if it is type string. So that is the isString function. And then we have another function here. So function print ID. So I'm going to grab the ID and have it type as a number or string. I'm going to see if is string, or pass in ID. Then we're going to console log ID to uppercase. So we're going to make it uppercase. Else we'll console.log ID. And basically we're doing a check on the type of this object through this isString function. And it's a great way to write some defensive logic. So you're basically checking to see if something is of this type, and if it is, then we return this bit of code. And that is essentially type guard. So we're going to go check to see if this works by passing print ID, and we'll put in the number 3. Let's go have a look. So if I refresh this, we just need to make sure we go to the page component and just make sure the import is correct. Okay, so we've popped in 3 here, and we can see that it is of type string. So then it's accessing it, and then it's displaying it as uppercase. So we can see that that works, and that's displaying it as we want. And that essentially is type guards. So next we're going to look at utility types. So TypeScript provides utility types like partial, pick, omit, and more that are helpful in Next.js projects. And that basically is a very clever way of doing batch permissions or batch actions on all types with these utility types. And I'll show you what I mean. So we'll create a interface here of user, and we'll do ID number, name string, email a string here. And basically what this does is this describes the user object that we want of user. And the next thing we want to do is define a function called update user that makes 2 parameters. So that is function update user, and it takes the parameter of ID, which will be number, and that's a unique identifier of the user to update the user. And the next one is updates, and we are going to do a partial utility type for the type user using the user generic here. So partial is a TypeScript utility type that makes all properties of type T, which is basically what this is, optional. So you can see partial T, and in this case partial user means that the updates can have a combination of ID, name, and email as optional properties, or it can have none at all. And then within here you would just update your logic for whatever that would be. But the main point here is just kind of show you this partial and how it works. So the key point here is that updates here can include any subset of user properties or none at all, which is these here. So you can pick and choose which one you want to use as a way to update this. So for example, we just might want to update the user email. So we'll do update user, and we'll say 1, and then we'll pass in an object, the user object, and we'll say we just want to update the email. We don't want to update everything else. So we'll do new email at gmail.com, whatever it is. And it's a really clever way to basically make your functions or your logic leaner and cleaner. And also with utility types, you could then update the user object with multiple different things. So you could do name and email. So name, you could do Harry, and email, you could be Harry at email.com. Or you could simply just update the user with nothing, and you could just say, I don't want to provide any updates at all, which is still a valid use case of partial. So this is a partial utility type. Now let's show you how it is to use the pick and omit utility types. So we'll just delete this for now, and we'll do pick here. So as well as email, we're going to add address of string and phone number as well. And then we're going to go create a new type called user contact info equals pick user, and we're going to say email or phone. So pick is a TypeScript utility type that creates a new type by picking a set of properties K from type T. So it's essentially a range. In this case, user contact info is a type that includes only the email and phone properties from the user type from that range of properties we could use. Now, emit is slightly different. So emit is a TypeScript utility that creates a new type by omitting a set of properties K from type T. So I'll show you what that means. So type user without address, and what we'll say is we'll omit user, and we're going to omit the address. And that what that would result in is essentially we're passing the user object within user without address, and we're just taking out the address within this type, and we're passing all this information, and that's what we're expecting. So it's a great way of refining the types. It's a great way of refining the data in a way that you need it. So you don't have to just fully accept all the information that you're given from an object. You can cut, change, and chop using TypeScript. And that is the power of utility types such as pick or omit. And there we go. Those are utility types in TypeScript and React. Again, these types of things that we say TypeScript and React, you can use them in Next.js as well. But these are some of the most important TypeScript utilities and features that you probably do need to know about. And especially when you go read a code base, these are some of the things that you'll need to know. And obviously the later, more advanced ones aren't things that you necessarily need to know to get your first job, but they are good to know as you mature into a mid-level and senior developer later on, and you're going to work in code bases that are maintained by mid-level and senior React TypeScript developers, especially in Next.js. So in this crash course, you've learned the basics of TypeScript and how to effectively use it within a Next.js project. By mastering TypeScript, you can build more robust, maintainable, and scalable applications. TypeScript's integration with Next.js enhances your development experience by providing strong typing, which helps catch errors early and improves the overall quality of your code. Now, what I would suggest as a few next steps after this crash course is just apply it in some of the projects you've built already. So for example, the CRUD app we just built, you could go in and make that completely type safe if you want, or just build another project of your own, a Next.js or React project, and try to add TypeScript to it. You can also go ahead and explore some advanced features. So dive deeper into advanced TypeScript features like advanced types, decorators, and TypeScript with React hooks. You can also explore some of the documentation within your Next.js project. So if you just go and have a look through some of the types and just read some of the properties and get a feeling of what they are, read some of the comments and explore more advanced features like that. You can also just go to the documentation, which is what I would suggest, and essentially have it bookmarked and start reading through it, and just regularly refer to the TypeScript documentation and Next.js documentation for the latest features and updates. It's a great place to be connected to all the biggest changes coming to front-end development, because Next.js, React, TypeScript, JavaScript, this is where all the big stuff is happening, and this is where all of front-end development is moving forward. So going onto the documentation and reading what's going on, reading through all the features is how you're really going to shine in an interview, how you're really going to shine in a work environment when you actually have to use these things in practice. And it's a really good way to advance forward in your career if you can start building these practices that senior developers use all the time. So by integrating TypeScript into your Next.js projects, you'll be well on your way to building powerful, type-safe applications. And that concludes your TypeScript crash course.